Hi all, welcome back to software engineering course. Let's get started. In last class we had studied about different styles of CNC view. We had seen pipe and filter, shared data and client server. We will continue our discussion with the same. Today we will see about the other styles of the same CNC view, that is publish subscribe style. The second one is peer-to-peer style or object-oriented style, and the last one is communicating process styles. So altogether we have six different styles for CNC view. Okay, the first one is publish subscribe. So here there are two components. One is publish, it will generate or publish the events, and the other one is subscribe. So what it will do, this component, subscribe component, it subscribes to a set of defined events. Now, in response to these events, the components that have published their intent to the process, the event are invoked. The events could be your mouse click, and components are assigned to those mouse click. Okay. So when an event occurs, the associated component is executed. As in case with most connectors, it is the task of runtime infrastructure to ensure that this type of connector, that is publish subscribe, is supported. We can see this style as a special case of Blackboard style, except that we do not have the repository concept here. Okay. Next one is peer-to-peer style or object-oriented style. So if we take the client server style and generalize each component to be a client as well as server, then we have this style. The components are peers. Okay. So we had seen the client server style, right? So suppose this is a client and this is a server, and it was communicating. The client was sending the request to server and server was responding for the client. Now in peer-to-peer style or object-oriented style, what happens is each component will act as a client as well as server. That means this could act as client and server, and this server can act as server and client. Both the features are given to the components. Like one will act, all the components which are connected to each other will act as a client as well as server. So components we call here peers, and any component can request a service from any other component. The object oriented computation model, it represents this style. So if we view the components as objects and connectors as method invocation, then we have this peer to peer style. Getting it? The next one is communicating process style. So this is the oldest model of distributed computing. Now communicating process style, it tries to capture the model of computing. The components in this model are, we call the components in this model as threads or processes. Now these processes or the threads, they communicate with each other with a message passing or through shared memory. This style is used in some form in many complex systems which use multiple processes or threads. Next, you have a quiz. So the question is, how many connector type are present in client server style? You have got 2 minutes. Okay, time up. Next, we will see how to document this architecture design. So far, we discussed like representing the views through the diagrams. So these diagrams are, a good way to explore options and encourage discussion or brainstorming between the architects. So when the designing is over, the architecture it has to be communicated to proper stakeholders, and why it has to be communicated, because for the agreement and negotiation. So the this requires that the architecture is to be documented properly with enough information, so that different stakeholders can see this document architecture or see the architecture document, have a knowledge about without a properly documented description of the architecture, so it is not possible to have a clear or common understanding. So documenting your architecture is important as if you are creating one. You have to create the architecture and you have to maintain it, document it properly. So just like different project requires different views, just like different project require different types of view, your different projects will need different level of detail in their architecture documentation. So whenever you are documenting a architecture, it should have the system and architecture context. Second, the description of the architecture views. The third, across view documentation. So we'll see this one by one. So we know that the architecture for the system is driven by the system objective and it needs and the needs of your client or the stakeholders. So the first aspect in that architecture document, it should contain the identification of the stakeholders and their concerns. Now the first portion, it should give an idea of overview of the system, like different stakeholders, the system properties for which the architecture will be evaluated. A context diagram, it establishes the scope of the system, its boundaries, the actors that interact with the system, sources, sinks of the data can also be very useful. A context diagram is frequently it is represented by showing a system in the center and its connection with the people, including sources and sinks of the data. So I guess you remember what is a context diagram. We had studied this in the last chapter. Okay. So this context diagram would be useful in the initial stage of architecture. So once you have defined the context of your system, or say suppose once you have given all the requirements and the architecture, the overview is done. The next thing is describing the different structures or describing the views. So multiple views of different types may be needed. So we had seen different types of views, right? So the multiple different types of that can be needed. So which type of view is needed? It would be based on your project as well as its stakeholders. The description of the views in the architecture documentation, it will almost always contain a diagrammatic representation of a view, which is we sometimes call it as primary presentation of the view. In any of the view diagram, so you have different symbols and different element types coming in, right? So we should have different types of components, we should represent them using some symbols, and these symbols should be unique and it should be clear to the reader. It should not using a component should not cause any confusion to your stakeholders. Okay. Say suppose whenever you are drawing architecture, you have the complexity, say suppose it increases, then what you can do is instead of having one architecture, you can divide it and you can have a hierarchical approach. So okay, now we had seen like the overview of the architecture, like the first one, the context. Once context is defined, then you have the architecture view. So once the view is represented, how you can maintain the document, right? Now say suppose these all things whatever we talked, it only discussed about the diagrams, only pictures, right? So every time, the 100% pictorial representation is not complete description of the view. The diagrams or the pictures, it gives you a basic idea of the design, but only if you provide only the diagrams, it is not sufficient. You should provide some other details. Say for example, The purpose of the functionality of a module or a component is indicated by only its name, which is not sufficient. Okay, whenever you want to, you have a, say suppose, for example, you have library management system and you have developed the architecture for that. Say you have given search as one functionality, say in use case diagram or in DFD, you have just mentioned search. Now what should that do, right? So you should also give, apart from your architecture, apart from the diagrams, you have to give supporting documentation. So what are the supporting documentation for these view diagrams? So your supporting documentation, it should contain, or it should contain some of the following or all of the following. So those things are the element catalog, architecture rationale, behavior, and other information. We'll discuss this one by one now. What is the element catalog? It provides the information about the elements shown in the representation, primary representation, or your view. Okay, so it, besides describing the purpose of the element, it should also describe the elements interfaces. All the different interfaces provided by the elements should also be defined. So interfaces should have a unique identity, and the specification should give both syntactic and semantic information. Syntactic information, such as your signatures, which describe all the data items involved in the interface and their types. Semantic examples, like what does the interface do. Okay, and it should also give the description about state of the error conditions. Suppose if interface, whenever it is communicating, some error occurs, what should be done. Even that should be present in your element catalog. The second one is architecture rationale. So it gives the relationship between the elements. It does not provide any insight into why the architect chose that particular structure. Okay. Now your architecture rationale, it gives the reason for selecting different elements and composing them in the way it was done. Okay. The next one is behavior. So your view or the pictorial representation, it gives you a structural information. It does not represent the actual behavior or execution. So in a structure, all possible interaction during a execution are shown. Sometimes it is necessary to get some idea about the actual behavior of the system in some scenarios. Say suppose, say it's a deadlock. What should be done? The behavior of your system should be, uh, in the case of deadlock, should be written down properly. Okay. The last one is other information. So this section may include a description of all those decisions that have not been taken during the architecture creation, but they have been, purposely left for the future, such as the choice of the protocol or choice of server, etc. Okay. So your architecture document, it should, besides describing the view, it should also describe the relation between different types of view. This is the primary purpose of across view documentation. Next, we will study how to evaluate the architectures. Your architecture of a software system, it impacts some of the non-functional quality attributes of the system, such as performance, modifiability, reliability, portability, etc. Okay. Now the architecture should be evaluated to see that it satisfies the requirement. A common approach to do a subjective evaluation is with respect to the desired properties. The attributes such as usability are only mildly affected by the architecture. Then how, a proposed architecture should be evaluated for these attributes? So some attributes like your performance and reliability. So for this, it is possible to build a formal models or diagrams using techniques like queuing networks and use them for accessing the value of your attribute. So another approach is procedural. So it is a sequence of steps that is followed to evaluate the impact of the architecture on some of the attributes. So one such informal analysis approach uses the following steps. First, what we have to do is we have to identify the attributes of interest for which the architecture should be evaluated. That means suppose it is a performance, reliability, availability, whatever the quality, attributes are there. So what we have to do, we have to ask our stakeholders interest. That means in what quality attribute they are interested in. We have to get a list of these attributes from from the stakeholders. Then whatever the stakeholders give us the quality attributes, right? So these have to be maintained in a form of table. Okay, first we have to take the the non-functional quality attributes from the stakeholder. Then we have to put them in a table. Then for each attribute, an experience based subjective analysis is done to assess the level supported by the architecture. Now, this analysis might mention the level of the each attribute, like the performance. Suppose for example, if I take a performance, so in that table, quality attribute would be my performance. Then based on the experience, I can tell like whether the system is performing good, average, or poor, whether the performance is good, average, or poor. Or say suppose reliability or security, what is the um, level of it, like whether it is excellent or poor or average. So in a table we have to mention all these attributes and their values, like whether good, average, or poor. Now, based on the outcome of this analysis, the architecture is accepted or can be rejected. So, once you take all the quality attributes from the client, you analyze them, you give some values to them, whether it's performing well, poor, or average. Then you submit this to your stakeholders, that is the client. Now, your client will decide based on these requirements or the quality attributes. They will decide whether to accept your architecture or to reject it. If accepted, it's well and good. If rejected, what you have to do is you have to again take those non-functional requirements. You have to enhance to improve its performance and performance for all the attributes. Again, then what you have to do after modification, you have to resubmit the architecture to the client. Okay, this is how we can have our architecture validated. Okay, next we will see about planning a software project. Till now, we had discussed about the architecture. Next, we will study about planning the software project. Okay. Now, this planning a software project, in this, we will first see the effort estimation, the types of it, project schedule and staffing, quality planning, risk management planning, the concepts, assessment, all those things. Then project monitoring plan. Then the last one would be detailed scheduling. Okay. We'll get started with this. Okay, the first thing. Have you ever planned, whatever maybe, have you done any planning in your life? The basic example I could give you is like, say, suppose you want to reach the college by 9 o'clock in the morning. So, how do you plan your day then? So, probably say by 8, 8:15, you'll be at the bus stand, you'll take the bus by, 8:55. Say, suppose you have reached the college. So you would have made some planning before doing all these tasks, right? So this is a basic example what I can give you. Or say suppose while preparing for your internals or the externals, how do you do? So say suppose some exams. So you will usually you'll do prepare a timetable and you act accordingly. You read accordingly. So you have a plan in picture, right? Okay. So the next one is why planning is necessary. Say suppose you have not planned a day. We'll take the same example of reaching college by 9 o'clock. Say you were late that day, like you got up late and everything was late by 10-15 minutes. You missed the bus. So what will happen? You reach late, right? So why planning is necessary? We say planning is necessary so that we can reach to our goal, right? Then why do you think planning is necessary in software project? So we had taken simple examples of your day-to-day life and we had seen like have you planned, why did you plan these all things. Now why planning is necessary in software project? Can't we do a project without planning? If we get the requirements, we can directly go on developing it, we can test it and then give it to client, right? Why we need a plan there? So the important things in the software project are like we have to develop at reasonable cost in the schedule, and the quality goals of the project must be met. A project succeeds if it meets its cost, schedule, and quality goals. So, without the project goals being defined, it is not possible to declare whether the project has succeeded or not, right? So, we need planning in a software project. So, this is the main reason why we need planning, so that we can tell whether the project is going in a correct path, whether we are following the time, we are either, we are into the budget or we have exceeded it. For all those things, we need planning. And this starts before your development and all. Okay. Now, what is the basic goal of planning? The basic goal of planning is to look into the future and identify the activities that need to be done to complete the project successfully and plan the scheduling and resources. Now, this is the basic goal of planning. So, planning, what do? You look into the future, right? You are identifying the activities that are needed to complete our project, right? Then, what could be the inputs to the planning phase? The inputs to your planning activity or the planning phase are your SRS, requirement specification, and the architecture description. When you have the architecture and the SRS in place, then you can start with your planning. Then what could be the output of it, right? What are the outputs? So the outputs are your project management plan and detailed project schedule. Okay. Your project management plan is a document. It establishes the project goals on the cost, schedule, and quality fronts and defines the plans for managing the risk, monitoring the project, etc. Then we have detailed project schedule. This is another output, right? So the detailed plan, we usually refer it as detailed project schedule. It specifies the tasks that need to be performed to meet the goals, the resources who will perform them, and their schedule. The overall plan, it guides the development of the detailed plan, which then becomes the main guiding document during your project execution for project monitoring. And if we have our plan in place, we can monitor and control our project. Okay. Then, what are the major issues your project planning addresses? There are some issues your planning phase that will address. So, those are process planning, effort estimation, schedule and resource estimation, quality plans, configuration management plans, risk management, and the last one is project monitoring plans. So, we will see some of these things in the rest of the chapter. Okay, the first one, what would we discuss? It would be effort estimation. So, for a software development project, your overall effort and the schedule estimates are essential. So, these are the essential things or the prerequisites for planning your project, the effort and the schedule estimates. Okay, now these estimates are needed before the development is initiated. So, your effort and the schedule estimates are needed as they establish the cost and the schedule goals of the project. So without these cost and the schedule goals, you cannot answer the question such as whether you have completed the project or your project is late, or are there are any cost overruns. You cannot answer these questions. So effort estimation is to be in place. So in this effort estimation, you are predicting the effort that is needed for your project. The effort could be in terms of your cost and the schedule. And you can also have like how many resources you need for your project. That can also be predicted in the effort estimation. Then why do we think the effort estimation is important? So Your effort estimation is important. Why? Because to check whether you are on track for the project, are you in the budget what is allocated to the project, or when what would be the time, like when you will complete the project. These all questions could be answered only when you have your effort estimation in place. There are two approaches for this effort estimation. One is top down approach and the one is bottom up approach. So we will discuss this top down and the bottom up approach in the next class. So before finishing, we'll have a quiz. The question is, what are the outputs of project planning phase? You have got 2 minutes of time to answer this one. Okay, time up. That's it for today. We'll conclude our session. Thank you.